So I think I said that I will be back with a better code than the previous time for the previous video of that SSM which was damped by friction force, constant friction force whose direction changes obviously. So now I'm back with that code. I think I said that, but I don't really remember if I actually said that, but assume that I said, and now I'm back. So uh, this much of the code I think is similar to what there was initially, right? So if I open up the previous code, so I just realized that this is a better way to open VS Code, which is by uh, opening the file with VS Code, uh, and I will close this. Yep, and I will do that. And this is the new code that I wrote, and the initial code was I just realized I deleted that. Yeah, so even though I don't have the actual code with me, I will show you a screenshot right over here. And if you see that, and if you look at this piece of code, those are exactly the same, but the only thing that has changed is like the way that I wrote, like here X, there I wrote, I think I wrote absolute, and in bracket I wrote X, I mean ABS, and then in bracket I wrote X, but here I wrote X in a different manner. And if you go about writing the absolute value as this in general, you will get an error, because this is not a standard way of writing. And also, if you see how I defined X and how I defined 0 and P, those are not the standard way of defining them. They are actually a different class of variables. So in the previous video, I think I said that it would have been better if Python stores data in the form of X by Y when you give the data in the form of X by Y. But I now realized while going forth with Python that you can actually do that, and to do that you can actually define a class which is fraction. This name does not really matter, but I chose it to be fraction because it really is fraction. So if you do that, I won't be like explaining every bit of it. Like if you can, if you see, you can get to know what every definition means. But like class is a bundle of few functions which act on that instance of that class. Sorry for this noise. Yeah, so where was I? Like, sorry for that noise again. What was I defining? So I was saying that if you look at each of the definition, which is in itself a function which acts on this instance of this class, which I defined by writing them in this bracket. Like you can know what each function does, each definition does. For example, this definition tells that it is true. What is true? Greater than, like self greater than A is true when this condition is satisfied. And in this, I am assuming that the denominator of this fraction is actually a positive number. So I am not taking into consideration the denominator for only that reason. That's basically it. And as I said, I won't be defining every piece and how to write this class, because that is a different topic altogether. But what I just wanted to say is, like, you can actually define such a class which stores value in the form of X by Y, the way you tell it to be. So it is actually beneficial, because if you see my initial code, oh, I forgot again. In that code, when you wrote this f to be 2, k to be 3, and x to be 4, you got something like 0.00010 to the power, no, not 10 to the power, like 10 to the power minus 16, and then it was on the positive or the negative side. But this is not the case with this code anymore, because now if you see, if I run this, and I put 2 here, 3 here and 4 here, you actually get that this is on the origin. This is only because how it saves now, it saves in the form of x by y and not it doesn't divide x by y, and that's really a great thing. That's all in this video. Bye for now.